So, okay, we simplify the given differential equation, become y double prime plus y prime equal to 2 sin x. So, step 1 will find the solution of homogeneous equation, where you let the second derivative by m squared, first derivative by m power 1. Mean we'll solve actually y double prime plus y prime equal to 0. So, then in this case, okay, m plus 1 equal to 0. So you have okay, m equal to okay, 0, m equal to -1. So the yc in this case will be, you have m is 0. So you have okay, this will be a, because e power 0x plus b exponent -x. So you have a plus b exponent -x. So in this case, what is the y1? What is the y1? If you have here, okay, yc is a plus b exponent -x. What is the y1? Aina. Okay, what is y1? Aina, are you around?
Yes.
What is y1? Because from yc, you need to identify y1 and y2. We said, okay, from the first term, you can obtain your y1 by eliminating the a. Mean, okay, delete a, so y1, what do you get?
Exponent 0x.
Yeah, exponent 0x, simplify it, what do you have?
Exponent x.
1.
Yes. Anything power 0, you have 1. That's why here, a, okay, exponent 0x is 1. Mean y1, eliminate your a, so it's just left 1 lah. So y2 is exponent -x. And then you find the okay, y1 prime, y2 prime. Then find the Wronskian. Where is it? I think got some technical problem to write. Okay, y1 prime, differentiate 1, 0. y2 prime, okay, differentiate exponent -x, you get negative exponent -x. Okay, and then you find, okay, the Wronskian. Okay, I put it here. Let's say your step 2, finding your Wronskian W, which is y1 is 1, y1 prime is 0. y2 is exponent -x, okay, y2 prime is negative exponent -x. Okay, like you're finding the determinant, so you got negative exponent -x. Okay, so your Wronskian you get is negative exponent -x. Takes your okay, main diagonal minus, okay, with product of the other diagonal. So 1 time negative exponent x, you get negative exponent -x. Okay, the other, okay, product of the other diagonal, you get 0. So Wronskian that you obtain, okay, is exponent -x. So step 3, finding the u. Okay, step 3, I put it here. Okay, u is negative y2 fx divide a divide w dx. Okay, you may put a here, or at the end you put up the constant a. Okay, y2 is put up exponent -x. The okay, fx is 2 sin x. Right. Okay, after we simplify, we have here fx is 2 sin x. Okay, a is 1. Your Wronskian is negative exponent negative x. So dx. So you have this one, negative, negative. So mean integrate, okay, you just left integrate 2 sin x dx. So you have, okay, negative 2 cos x, okay, plus a. So this is the u. Okay, later on you'll find the v, step 4, finding v, which is integral of y1 fx divide a divide w dx. Okay, y1 is 1, fx is 2 sin x. Okay, a is 1, w is negative exponent negative x dx. So in this case, you have negative 2 exponent x sin x dx. Right. Okay. You have here negative. So divide by exponent negative x, okay, bring k to numerator, become exponent x. So you have, okay, the product form of the integral of product form where you have exponent x sin x dx. So it's either you use, okay, integral by part, okay, but I would prefer to use the tabular method. Let me see. Maybe you have the product form in this case. Okay. I'm not sure whether in your calculus, okay, you learn the tabular method or not. Okay. So for this one, I will choose, okay, this is so-called the tabular method. You have sign, always start from positive. U, okay, is a term that you differentiate dv, like, okay, the, okay, integral of u dv, mean the integral by part. So u, if you have polynomial u, you can always choose as polynomial and differentiate u until 0. If you don't have polynomial, so which one to choose as u is normally you choose the term where you easy to differentiate. Okay, let's say I just choose u as a sin x, dv as an exponent x. dv you integrate, and then the sign start from positive, later on alternate negative. So okay, u here, the first sin x, and then differentiate sin x, you have cos x. Okay, integrate exponent x, still get exponent x. Okay, and then plus differentiate cos, you have negative sin x. So integrate exponent x, you have exponent x. Okay, if the u is not polynomial, and then, okay, you normally will just do 3 row where you get back the same term as in the first row, same term, but of course coefficient is different. You see here sin x, exponent x, then you stop. Okay, if u is polynomial, then you can differentiate until 0, then you stop it. Okay, and the result is actually you follow the arrow here. Okay, the slanting arrow is actually the result of the integral. The horizontal, okay, is actually carry the integral symbol. Okay, like your, okay, I put out your integral by part. Remember, you have integral of u dv. The result is uv minus integral of v du. So it's a simple. So this is, okay, you integrate. So this is v, this is du. Okay, so I'm going to put up here. This one, put it here first. So the integral of exponent x sin x dx. Okay, if follow the slanting arrow, you have exponent x sin x. Okay, the second slanting arrow, arrow is negative cos x exponent x. So I have factor out exponent x, so I have a negative cos x. Horizontal is actually v du, like in your integral by part. Tubular method is actually come from integral by part, but it's a systematical way, because if you do integral by part, you have to do several times. So this one is a systematic way we put in the table form. So the horizontal row, so positive negative sin x multiply exponent x, this is actually so you have positive negative is negative, carry the integral symbol because it's integral of this is v, this is du, because from dv we integrate we get v, u we differentiate we get du here. So this is an integral of exponent x sin x dx. So we collect, you can see that left side, one time exponent x sin x dx, right hand side is negative integral of exponent x sin x dx. When you collect it, you have two time integral of exponent x sin x dx. The result is exponent x bracket sin x minus cos x. And then you want, actually you have plus c. So if you want one time of exponent x sin x dx, the result, here you divide by 2. So exponent x over 2 multiply sin x minus cos x. So this is the result of integral exponent x sin x dx is exponent x divided by 2. So here, so you have negative 2 divide by 2, mean the result here put back here, exponent x sin x minus cos x. So this is plus b. Simplify it, you will get negative exponent x sin x minus cos x plus b. So you obtain u and v, plug in u and v into the general solution, where you got step 5, the general solution is actually the y is u y1 plus v y2. Where is the u? U is here. U is negative 2 cos x plus a. Negative 2 cos x plus a. Multiply y1. Y1 is 1 times 1. V is here, which is negative exponent x. Bracket sin x minus cos x plus b. Multiply y2. What's y2? Y2 exponent negative x. And then collect like yc. Mean the collect the term with a and b. So a times 1 you have a. So this is b exponent negative x. And then you have here negative 2 cos x times 1. So you got negative 2 cos x. And then this one negative exponent x times this term exponent x times exponent negative x, we have exponent 0, which is 1. So 1 times this one, so mean minus sin x negative negative plus cos x. So you should have a plus b exponent negative x, so minus 2 cos x plus cos x, so minus cos x minus sin x. So for your module here, if you want the original questions, the answer should be this one: a plus b exponent negative x minus cos x minus sin x. Okay, or else you change the question dy dx to y. Okay, you may check the solution using a mapper. Okay, any one of you having difficulty to download the mapper? If you cannot, you can find, I think just go to the online tools. If you cannot download, then you have to use the online tools to do your solve the ODE. Okay. Okay, where's the question just now? Where's the is a y double prime plus y. Okay, second derivative. This one. Yeah. We want second derivative. Okay, f change to y x. Yeah. Okay, this is y double prime, which is d2y dx2. This one change to y, so plus y x equal to 2 times sin x. Okay, and then you can just call the d solve differential means solve the ODE. D solve ODE for yx. So C1, you can tally it with A, so you have A cos x. C2 is a B, so A cos x plus B sin x. The sin x here, you can collect it to the term C2 sin x. So the YP is actually only negative x cos x. This one, if you change to y, the question, if you change it to y, you should get as given solution a cos x plus b sin x minus cos x. And then if you want the original questions there, the wrong questions there, this one I can Control C, this one. So you see the solution, you have C2 is A, C1 is B. So you have A plus B exponent negative x, then minus sin x minus cos x. Is it correct? Minus sin x minus cos x. Is it clear? The example 2.9 is you want the same solution, change dy dx to y. After that, example 2.10, they have a mistake.